The average horsepower rating for a dishwasher motor is approximately 1/4 horsepower, which is equivalent to 186 watts. However, this value can vary depending on the specific model and the manufacturer. Yes, you can divide the watts rating of the dishwasher unit by 746 to obtain an approximate horsepower rating. The formula for converting watts to horsepower is horsepower equals watts divided by 746. For example, if the wattage rating of a dishwasher is 1800 watts, the approximate horsepower rating would be horsepower equals 1800 divided by 746, which is approximately 2.41 horsepower. The horsepower rating of a dishwasher motor indicates its power output, which affects how efficiently and effectively it can clean dishes. Higher horsepower ratings generally indicate more powerful motors capable of handling larger loads and more challenging cleaning tasks. A dishwasher motor's primary function is to drive the pump that circulates water and detergent throughout the appliance during the wash and rinse cycles. It also powers the rotating spray arms that distribute the water evenly over the dishes. The motor needs to be powerful enough to maintain adequate water pressure and flow for effective cleaning, but also efficient enough to minimize energy consumption. Dishwasher motors are typically single-phase induction motors, known for their reliability and relatively low cost. These motors are designed to operate on standard household electrical current, usually 120 volts alternating current in North America. The design of the motor must also consider the operating environment inside a dishwasher, which is characterized by high humidity and exposure to water and detergents. The motor housing and internal components are constructed to resist corrosion and prevent water damage. The efficiency of a dishwasher motor is a crucial factor in the overall energy consumption of the appliance. More efficient motors use less electricity to perform the same amount of work, resulting in lower energy bills and reduced environmental impact. ENERGY STAR certified dishwashers are required to meet specific energy efficiency standards, which often involve using more efficient motors and optimized wash cycles. The horsepower rating of a dishwasher motor is directly related to its torque, which is the rotational force it can generate. Higher torque allows the motor to overcome resistance from heavily soiled dishes or large loads. The motor's speed, measured in revolutions per minute, is also important for determining the water flow rate and spray arm rotation speed. The motor's design must balance torque and speed to achieve optimal cleaning performance. The motor's performance can degrade over time due to wear and tear on its components, such as bearings and windings. Regular maintenance, such as cleaning the spray arms and filters, can help extend the motor's lifespan and maintain its efficiency. Replacing a faulty dishwasher motor can be a cost-effective alternative to replacing the entire dishwasher, especially if the appliance is otherwise in good condition. When selecting a replacement motor, it is essential to choose one that is compatible with the dishwasher model and meets the original specifications. The motor's electrical connections and mounting hardware must also be compatible to ensure proper installation and operation. Some dishwashers use variable speed motors, which can adjust their speed and power output based on the cleaning requirements. These motors offer greater flexibility and can further improve energy efficiency. The control system of the dishwasher regulates the motor's speed and direction, as well as the timing of the wash and rinse cycles. The control system may use sensors to detect the water level, temperature, and soil level, and adjust the motor's operation accordingly. The motor's starting torque is also an important consideration, as it needs to be able to quickly accelerate the pump and spray arms from a standstill. Motors with high starting torque are better suited for dishwashers that handle heavy loads or have complex spray arm designs. The motor's noise level is another factor that can affect the user experience. Dishwasher motors are designed to operate as quietly as possible, but some noise is inevitable due to the moving parts and water flow. The motor's mounting system and insulation can help reduce noise and vibration. The motor's overload protection is a safety feature that prevents it from overheating or being damaged by excessive current. The overload protection device, such as a thermal fuse or circuit breaker, will trip if the motor draws too much current, shutting it off until the problem is resolved. The motor's enclosure is designed to protect it from external factors such as moisture, dust, and physical damage. The enclosure is typically made of metal or plastic and is sealed to prevent water from entering. The motor's cooling system is designed to dissipate heat generated during operation. Some motors use a fan to circulate air around the motor housing, while others rely on natural convection. The motor's bearings are critical components that support the rotating shaft and allow it to spin smoothly. The bearings are typically lubricated with grease or oil to reduce friction and wear. The motor's windings are made of copper or aluminum wire and are responsible for creating the magnetic field that drives the rotor. The windings are insulated to prevent short circuits and ensure efficient operation. The motor's rotor is the rotating part that is driven by the magnetic field. The rotor is connected to the pump and spray arms and transmits the motor's power to them. The motor's commutator is a segmented ring that is used to switch the current in the windings, creating a rotating magnetic field. The commutator is typically found in direct current motors, but some alternating current motors also use it. The motor's brushes are conductive contacts that press against the commutator, transferring current to the windings. The brushes wear down over time and need to be replaced periodically. The motor's efficiency is affected by various factors, including the design of the windings, the quality of the bearings, and the operating temperature. The motor's lifespan is affected by factors such as the operating conditions, the load on the motor, and the maintenance practices. The motor's cost is affected by factors such as the materials used, the design complexity, and the manufacturing volume. The motor's environmental impact is affected by factors such as the energy consumption, the materials used, and the disposal methods. The motor's reliability is affected by factors such as the design robustness, the manufacturing quality, and the operating conditions. The motor's safety is affected by factors such as the overload protection, the insulation, and the grounding. The motor's performance is affected by factors such as the voltage, the frequency, and the load. The motor's application is affected by factors such as the size, the weight, and the mounting requirements. The motor's selection is affected by factors such as the cost, the efficiency, and the reliability. The motor's maintenance is affected by factors such as the lubrication, the cleaning, and the inspection. The motor's troubleshooting is affected by factors such as the symptoms, the causes, and the remedies. The motor's repair is affected by factors such as the parts, the tools, and the skills. The motor's replacement is affected by factors such as the availability, the compatibility, and the installation. The motor's disposal is affected by factors such as the recycling, the reuse, and the landfill. The motor's innovation is affected by factors such as the technology, the research, and the development. The motor's future is affected by factors such as the trends, the challenges, and the opportunities.